Um, so according to the tutorial, we only running the one hot encoder on the training Y, and one hot encoder is basically, to be honest, I don't really know the difference between one hot encoder and the whole tokenizer crap. All I know is one hot encoder seems to be a lot easier to implement. As shown in the code right here. Well, I think we're camera zoomed in right now, but yeah, the code is actually really easy. You just gotta press type one hot encoder. But okay, so then we got the data pre-processed because one hot encoder turns the thing into integers and tokenizer turns the x, the training x and test x into integers. So now we keep going. Oh, and now we can actually define the model. Okay, I love this fucking part. Let's go. Alright, now I'm gonna actually learn. This is the actual harder part. Okay. Okay, so I'll probably erase all of these to be honest. Like as long as personally, like when I write stuff down, I kind of just remember it. Like, this is just for like processing my brain. So I'm gonna erase all of this. And then the model actually looks like let me move it over here. Um. So I just basically wrote the code for according to the tutorial what the model looks like. I don't know if through the camera this plays it well. Sorry if it doesn't. But this right here, model equals sequential, and then the Keras model adds an embedding layer. The Keras model adds then the LSTM layer. The Keras model then adds a repeat vector, and then the Keras model adds an LSTM layer again. And then I don't know what the heck is time distributed actually, but I'm gonna kind of like try to memorize what it does right now, what like embedding LSTM does right now, and then because I know that in Coursera we actually did the same thing. So there's actually a graph for this whole thing. So this is time for me to solidify my knowledge, and so let me try to remember what this whole thing does from scratch. So to be honest, I don't know what a sequential do. I have no idea what it does. I think it starts like a model, and then the embedding layer is this. We turn the words, so the words don't actually, the words need some sort of meaning to it, and this embedding layer gives it arbitrary kind of like features. So for example, like an apple and a lemon are actually more alike to each other versus like, I don't know, an apple and a rock. So how do we actually capture this meaning is by giving this one a feature. So for example, an apple's feature can be food, and food can be 1. So our model is going to learn that food. There's going to be a small mini neural network to itself. The neural network, small neural network, is going to learn that maybe for apple it's going to have a hidden feature that of course we don't actually know, but it might resemble something like food. It's going to be 1. And then for lemon, food is going to be 1, 2. It's also going to be 1. And then there's going to be something else that's going to be really similar. Fruit maybe 1, and that last color is going to be completely different. And then so the same as apple for rocks. They're gonna, I mean, they're not the same for apple and rocks. They're gonna have really different things. So that's what the embedding layer learns. So I'm not understanding a few things. For example, what is n units here? Why do we need the n units? Let me see. Embedding layers, we need to put in the source vocab. That makes sense. Let me think. I think that makes sense. Yeah, so since it's trying to learn its own stuff. And then the timestamps. I'm not sure what the timestamps gonna look like. Yeah, I'm gonna look at the graph later for that one. And then we have the LSTM layer, which is the, oh, I actually forgot what LSTM stands for. I think it's long short-term memory. And then LSTM cell basically is good for sequential. So LSTM cell actually look like there. That's LSTM cell. We input the first, I think it was the X, and in this case it's going to be the embedding, basically the embedding vector. And of course it's going to be looking like 0, 1, 0.75, I don't know if there's negative, 0.17, da 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 da. However much embedding. Oh, maybe it's this part right here, the n units. So it might, like this n units here might represent how many embedding units that we want to have. Potentially, I don't actually know. And we put this into LSTM unit. LSTM unit is again this neural network is going to learn the stuff inside. But this is going to map out a y0, I believe. And that's going to be the first word. And then it's going to take that first word, put it into the second LSTM cell. So the input here is actually not embedding, but the y1 that it learned. And it's going to put in y2. And there's also going to be the hidden cells there that come here. So this is really interesting. When I learned this first like a month ago, basically what this does is that it allows the flow of information to keep going. So it's not trying to it's not trying to predict the third word based on just the second word. It's going to be predicting the third word of the sentence based on the first and the second word. That's what I'm really excited about. I think that's what LSTM does. I do have to check that, of course. And then we have the repeating vector, which I think it's a keyword in attention mechanisms, which I thought was missing at the beginning when I started doing this. That's really interesting, and I can do some research later. So I'm about to jump in Coursera right now to see if my stuff is correct. I think this is blocking this. I don't know. Well, it is blocking it, but I think back in week 3, I had a little thing. I think it's somewhere here with the tension thing. And if I open the notebook, I should be able to see it. And there's a really beautiful graph, I think. Yeah, this thing right here. This is extremely beautiful. I love it. Not this one. Wait, it is that one. Okay, so... Oh yeah, and there's LS, the other LSTM, post attention. Yeah, there is one after the repeating vector, which makes perfect sense. The repeating vector is attention mechanism, and then we put into another LSTM. So actually, this thing right here, the tutorial that I just did is probably almost perfect. Like, it's probably gonna be within the 3%, 5% accuracy versus some of the pro ones. And I might look into Blue Score, which is a standard way of measuring these machine learning translations. But we have this pre-LSTM here, which is what we modeled earlier, and that is indeed the, that I believe is indeed the embedding vector. Put into this, gonna learn stuff. This is one thing I don't know. I don't know how exactly like these are plugged into attention. It is showing the other graph. So right here, I have no idea why like these. First of all, this is really confusing. For some reason, all of these are called A1s, which I think is a mistype. I really do think it's a mistype. Because right here, like this is the attention right here is just shortened because it's actually captured all in here. We actually have A1, A2, and AT. So I have no idea what the inputs here are. A1, A1, A1. It's probably a mistype. So if it's a mistype, it's going to make a lot more sense. But we have this repeating vector, which I really don't get. Oh, it's this thing right here. But what the heck is this though? Why are we plugging that back into the... I remember this now. But do I know what it is doing? No. So that's the input hidden state. That's the initial hidden state for the post-attention LSTM. I don't know why it's plugged back into the original attention block though. I don't want to read all of that, to be honest. I can't process it. Anyway, so okay, that makes a little bit more sense though. Of course, the thing right here is that the attention is gonna be another small neural network that is gonna learn how much attention should it pay to generate this output right here. How much attention should it pay to these words based on their outputs? That's gonna be another neural network that's gonna learn itself. And then I really don't know why this is plugged into these, and the way they're plugged into these is by creating multiple copies of this. And that is done with repeating vectors, and then how many repeating vectors we create is the target time steps. Okay, this makes sense. This does make sense actually. Like the code here makes sense. The logic behind doesn't make sense that much. I can't. Okay, so the context thing is plugged in, and then we go to the post attention LSTM. This whole thing should make sense to me by now. Okay. And time distributed is, don't know where that comes from, but I know the dense thing right here is this layer right here. That will really computing the final outcome. And this y1, y1. Oh, it has to be a mistype. This should be y1, y2, y3, blah blah blah, and a yty. I don't know if you can see the yty. I think my webcam locates somewhere around here. So yeah, this is a yty. So there's a few mistypes. Now it makes more sense. So let me try to draw this graph from scratch without looking at this. So I should be correct with that. Let me read this. So I got the embedding vectors. I did not forget the initial state, but I should write A0. I did not forget that the first one is bidirectional. But I do not know that by each step what is it plugging into each other LSTM cell. But I believe by the graph it is saying that we're just from A2 to A1 we're plugging in A2. When we go into the attention, I got that part. I did not draw out specifically what attention does. So there should be a context that is computed. So I didn't forget about that. The attention itself is actually pretty complex, huh? I'm not feeling mathy today. I'm gonna skip that part. So, okay, I'm done with this. That's good, that's good. I remember the mottos. Okay, so I think I'm actually done with that part. Wait, am I done with the whole thing? Maybe, yeah. So let me read through this. We make the model, we train it, okay, and that's the entire thing, and it's actually going to look like this. That looks perfect, and it's going to train it, and then we can predict it. But I don't want to go through the whole prediction thing, to be honest. I'm not feeling it today. I feel really accomplished by doing this, so I think I'm not going to step further. Wait, I should keep conquering it, but I think I'm going to save my energy for tomorrow. It's only 5:33, but I got some... I kind of want to learn some game development today, so yeah. Okay. So we got a predict sequence here, which is really predicting the sequence. It's gonna call model.predict, and then the source should be a tokenized and converted to integer double array. Yeah, it should be a tokenized and converted to integer double array. So that's how we actually predict stuff. So how was I able to predict stuff earlier? Because my test set is tokenized, and I was predicting on the test set. What if I do something else? instead of calling code sequences, I actually understand what it does. So I probably have to, I just made the source, but I probably have to, I made the source, I probably have to, what is it? Tokenize it. Well, I'm not gonna wait, do I tokenize this? I don't create a new tokenizer, because I already have that internal integer memory stored in the tokenizer. So all I have to do is to call the sequence to text thing, which I can find it. I think it's somewhere here. Okay, text to sequences. Hopefully this works. Am I expecting this to work? Not really. Where's my model? Please work. First try working is like the best feeling ever. Never happened to me, I think. Oh, I'm loading it afterwards, what the heck. Oh. Interrupt that. Okay. Work. Why is it not defined? I have to import it. Oh, let me interrupt this. I only need to run this part because loading the model takes pretty long. Shift enter. Okay. Text. I thought I had it. Interesting. Oh no, this is bad. I don't know how to retrieve the original tokenizer that I made for the test and training strap. It's gonna be really different if I fit one on this. So I guess I'll just call one of these polo. I do need a Spanish tokenizer, right? But do I still have it? Like, I really don't know how is it stored in my variable. It's actually an English tokenizer. That's pretty interesting. One array. Okay. It's probably gonna be looking like this thing. Okay. We're gonna do this. This works. We're gonna do this. Shouldn't work. So why doesn't this work? The list of NumPy arrays that your passenger model is not the size of the modeled expert. I don't have two arrays though. I have one array right here. This is interesting. Let me evaluate this. Okay, this is not working either. Okay, so that's fine. Why did it just work? What the heck? Okay, I don't care about this part. Why did this just work? Print the train, evaluate model. Hold up. Let me run this again. So I think model is incorporated in here already when I run it. So I don't need to do load again, or I can just move it here. Let me see. So I want to see what the test X looks like. Oh, so it's padded. That might be the reason it's padded. It's tokenized and padded. So this thing right here, source earlier was only tokenized, but I don't think it was padded. I'm gonna copy the logic from here. There's also this right here. So, yep. the sources at this point is expected to be padded already. So first of all, I need to do process source so that it is reshaped, tokenized, and padded. The source equals to it's supposed to still be like this. Hola mi amigo, and maybe ¿Cómo estás? ¿Cómo estás? With no accent. So I need to tokenize this. Where does it fit? No, it's sequence to this thing right here. And it was an English tokenizer. Dots. So I don't know why it's an English tokenizer, but since it puts it right here, I'll just put it right here. I don't really care. Yeah, it should be Spanish, right? Because this like should be uniquely for Spanish. I don't know. I don't care. And I'm gonna pad it. And I think the way you pad it is so length. Oh man, this is a little bit of work. Do max length source, and then it's going to return the max length, and then we can actually call this encode tokenizer thing right here. It returns a X, so we can just do source. The English tokenizer, it's a max length, and then we can do source. Source one. I never called split. I never called interesting. Let me just say max length is 3 because I know it. Nice? What the heck? Why is it 0? That's not right, but it's okay. Yeah, it's getting weird, so it's okay. Now I'll put this onto a different one. See you guys later.